Kuzambo, Bhutan e-learning project welcomes you to this lesson. My name is Sharab Jatso. This lesson is a physics lesson for Key Stage 4, which includes classes 9 and 10. In today's lesson, I'll be teaching to you about Ohm's law, and I'll be showing simple demonstration on how to verify Ohm's law, and towards the end of the lesson, I'll be also showing to you all how to do simple calculation using Ohm's law. Okay, my dear student, by the end of today's lesson, you should be able to, number one, state Ohm's law very clearly. Number two, you should be able to describe the relationship between current, voltage, and resistance in your own words. And number three, you should be also able to solve some simple calculation or problem based on Ohm's law. So these three are the important objective for today's lesson. Now, before I really go into today's topic, it is very important for us to get the foundation very clear, because if our foundation is weak, then we cannot build a very good house. So similarly, if you want to know the lesson very clearly, you should have a good foundation. So when I say foundation, in the world of electricity, in your lower classes, you must have learned about topics like charge. You must have learned about topic like current. You must have learned something like voltage, resistance, ampere, and lot more. We are not going to look at all these things because we are just going to sort out some very important things and then do a quick recapitulation. Are you ready? Okay, let's go. Now, as I've said earlier, we're not going to look at all the things that you have learned in your lower classes. We're just going to touch upon three important terms which is directly in line with today's lesson. And number one, we will be talking about current. Okay, what is current? Okay, current, as you all know, is rate of flow of charge. The amount of charge flowing in a circuit within a given time is called current. And current is represented by symbol capital I. You got it, right? Okay. What is the unit that we use to measure current? We call it as amperes, and it is represented by capital A. Okay, capital A. Now, the second question in the recapitulation section is, what is voltage? Yes, what is voltage? Okay, so by this time you must be already thinking about or recapitulating something that you have learned in your lower classes. Voltage is the driving force or potential difference between two terminals of a battery, and it will be represented by symbol VE. In some textbook, it is also called as EMF, electromotive force. And in order to measure voltage, we use a unit called volt, and it is also represented by symbol VE. Okay, then final question in the recapitulation section. What is resistance? Yes, you got it right. What is resistance? Resistance, as you all know, is the obstruction offered in the flow of charge. When charge flow or when current flow from one terminal to other, or when charge flow from one end to another, the obstruction offered in that flow of charge is known as resistance. And resistance is measured, the symbol of resistance is simple capital R, okay? Capital R. And resistance is measured in a unit called ohms, and it is represented by a symbol, Greek letter omega. So that is the quick recapitulation of current, resistance, and voltage from your lower classes. Now, let us look at our main topic. So first, I said we are going to look at the statement of Ohm's law. People have been trying to establish a relationship between different things, and in this particular context, a German physicist, Georg Simon Ohms, came up with a very, very important and useful relation, and this relation is what we are going to look at, that is Ohm's law. German physicist Georg Simon Ohms stated that the electric current flowing through any cross-section of a conductor is directly proportional to the potential difference applied across its end, provided the physical condition like temperature and pressure is constant. Let us read it once again together. Okay, are you ready? German physicist George Simon Ohms stated that electric current flowing through any cross-section of a conductor is directly proportional to the potential difference applied across its end, provided the physical condition like temperature and pressure is constant. Great job. Now, in the following section, I will do a simple demonstration on how it's actually working. Or in other words, we can say, let us try to verify the Ohm's law. So that is actually the verification of Ohm's law. Now, let us look at how to verify Ohm's law. In order to verify Ohm's law, we are going to specifically use a method called scientific inquiry method. In this method, we have to ask question, formulate hypothesis, plan and investigate, collect data, analyze data, and share. So this whole process is actually a scientific inquiry process. In asking question in our today's context, since we are trying to verify Ohm's law, our question could be, what is the relationship between voltage and current? What is the relationship between current and resistance? What is the relationship between voltage and resistance? So these are some of the questions that you could ask. And when we try to formulate the hypothesis, we can formulate hypothesis like, if we increase the voltage in the circuit, then the current is also going to increase, provided the physical conditions like temperature and pressure remains constant. And the third phase that we are talking about is to plan and investigate. So in order to plan and investigate, we need to have set of materials. So for this experiment, I have set of materials displayed here. So we will conduct a simple experiment to verify Ohm's law. This is the experimental setup to verify Ohm's law. So this is in the plan and investigation phase. So to begin with, I have two fresh dye cells, each with 1.5 voltage. This 1.5 voltage, 1.5 volts. And the positive terminal of the cell is connected to positive terminal of ammeter. And the function of ammeter here is to measure the amount of current flowing through the circuit. From the negative terminal of the ammeter, it's connected to positive terminal of voltmeter. The function of the voltmeter here is to measure the voltage across the resistance connected parallel to the voltmeter. And from this negative terminal of voltmeter, it is connected to upper end of the rheostat. Before I talk about the function of the rheostat, you may be wondering what is this particular thing. So here I am connecting a resistance, 50 centimeter resistance here, a metallic wire, parallel to the voltmeter. So this will provide the resistance to the flow of current. Now this device is a rheostat, and the function of the rheostat here is to regulate the amount of current flowing in the circuit. So I can shift this different direction to adjust the amount of current flowing through the circuit. From the lower terminal of the rheostat, it's connected to first end of the key. So when I keep the key like this, we call this as an open key. It is as good as keeping the circuit off, the switch off. But when I put the key, insert the key, this is a closed key and the circuit will be complete. And then from the another end of the key, it is connected to negative terminal of the cell. Hence, this is the complete setup to verify the Ohm's law. Now, let us take some reading to investigate the change in current and voltage and then verify the Ohm's law. So in order to do it, I'll close the key and then I'll try to regulate the amount of current flow here by dragging. Okay, so let us take our first reading from here. So if you look at the voltmeter reading, it is, so you can directly see from there, so it is at 0.25. 0.25. And simultaneously, the amount of current flowing through the circuit at the particular time is 0.1. Now, the next step. So let us try to adjust the amount of current flowing through it. Okay. Now, when the amount of the voltage here is 0.5 volt, 0.5 volt, simultaneously the ammeter reading shows the amount of current in the circuit as 0.2. Okay, let us take third reading. Let's try to take the equal interval so that later on we will not have problem when you try to plot the graph. Now when we try to adjust the voltage, the amount of the potential difference at 0.75, the amount of current is 0.3. The amount of current in the ammeter is 0.3. Okay, now let's take the fourth reading. So let us try to adjust the voltage at 1 volt. Okay, so our fourth reading, when the potential difference is 1 volt, the amount of current flowing through the circuit is 0.4. And let's take one more reading, so the last reading. Okay, so let's take the last reading, and when we adjust the rheostat at this position, so our voltmeter reading is coming at 1.75. The corresponding amount of current flowing through the circuit when there is 1.75 volt is 0.7. So with this we have already taken 5 reading. So now let us try to plot a graph and find the slope of V versus I graph and see the resistance, the constant there.
Okay, my dear student, since we have already collected the data as plotted or shown in the table, now let us try to interpret those data and make some sense out of it. So we are going to plot a graph, and the graph is as shown. So as you can see clearly, along the y-axis we are taking voltage measured in volts, and along the x-axis we are taking current measured in amperes. And this graph is a VI graph. So we have 5 different plots, and when you join it, it is a straight line. Now, in order to make sense out of it, we have to calculate a slope. And the slope of the graph is given by a formula, rise over run. Rise is change in y-axis and run is change in x-axis. If you look very clearly and carefully into the graph, you will see that change in y-axis is 1 minus 0.5, and change in x-axis, that is run, is 0.4 minus 0.2. So we are getting 0.5 divided by 0.2. So the answer is 2.5. As you have seen clearly in the table, 2.5 is our constant resistance. So from the graph also, we concluded that the slope is 2.5, which means that resistance is constant.
Okay, my dear student, with this we are done with the verification of Ohm's law, or you came to know the relationship between voltage and current. Now let us look at one very interesting simulation, that is interactive PhET simulation, to make us further clear on the relationship between current and voltage, current and resistance. Okay, my dear student, since we are already done with the verification of the Ohm's law, to make the concept further clear, let us get help of the PhET simulation. So this is the interactive PhET simulation, and if you look at the display here, you will see that the statement of the Ohm's law is already described or presented here, that is voltage is equal to current times resistance. And if you look here, we can vary the voltage and increase it and decrease it. We can vary the resistance, we can increase the resistance, decrease the resistance, we can play on with it. And this is the circuit diagram for that particular verification. Now let us get into the real concept. if you try to change the voltage, if you try to change the voltage here, increase the voltage here, as you can see from the size of the VE and then additional pop-up of the cells. So you'll see that with increase in the voltage, you will also see that the arrow is becoming bigger, which means that current flowing through the circuit is also increasing. With the decrease in the voltage, you can see that arrow is becoming smaller, and then current I here is also becoming smaller, means that there is a direct relationship. With increase in voltage, current also increases. With decrease in voltage, current also decreases. As you have seen in the simulation a moment ago, with increase in voltage, the current also increases. With decrease in voltage, the current also decreases. I'll repeat once again. With increase in voltage, current also increases, and with decrease in voltage, current also decreases. So this means that there is a direct relationship between voltage and current, and in scientific term or in physics we call this as directly proportional. That is, voltage is directly proportional to current. Now let's play with the resistance. Here resistance is given is 293 omega. So let us see what is happening if we try to increase the resistance. Okay, you see the R is becoming bigger and bigger, but what's happening to the current? Can you see I? I don't see it. It's becoming invisible now. So we can clearly make out from here that with increase in R, our I is becoming smaller and smaller. So it means to say that we can conclude from this that there is inverse relationship between current and resistance. With decrease in resistance, you will see the current is becoming bigger. So when resistance is 10 ohm, you can see the current is 150 milliampere. So with increase in resistance, current is becoming less, current flowing through the circuit is less. With decrease in resistance, the current flowing through the circuit is more. So there is an inverse relationship between resistance and current. Resistance and current. Resistance and current. Okay, as you have seen in the simulation, again, when you try to increase the resistance, the current decreases. And when you try to decrease the resistance, current increases. So as you can see with the gesture of my hands, when current increase, resistance decrease. When resistance increase, current will decrease. So there is an inverse relationship. When current increase, resistance decrease. When resistance increase, current decrease. So there is an inverse relation, and this in physics is known as inversely proportional relationship. Inversely proportional relationship. So there is an inversely proportional relationship between current and resistance. That is, current is inversely proportional to resistance. Current is inversely proportional to resistance.
Okay, now in the third section, as I have already stated in the beginning of the session today, we are going to do some calculation related to Ohm's law. Okay, in order to do calculation, what do we need? If you want to go into farm or agriculture field, we need some tools. So similarly, in order to do some calculations, we have to be ready with some formulas. So for today's session, we are going to use a Ohm's triangle, commonly referred to as Ohm's triangle, to calculate the formula. So in this triangle, we have three divisions or three segments, and the upper segment is filled with V, and left side of the segment with I, and right side with R. Now, if we cover the upper segment, that is V, which represent voltage, we are getting I times R, that is V is equal to IR. That is what Ohm's law also stated. So this is our first formula. Then, if we cover I, what do we see? So we see V divided by R. V divided by R. That is, current is equal to voltage by resistance. Great. Now, let's look at the third formula. If you cover R, what do you see in the triangle? So you see V divided by I. Yes, V divided by I. That is, resistance is equal to voltage divided by current. So these are the three important formula we will be using in our problem solving. Question number 1. What voltage will produce a 0.35 ampere current through a 750 resistor? Okay, so as we are very much used to, when we see such kind of problem, first we list the given things. So in today's case, or in this case, the given things are I is equal to 0.35 amperes and R is equal to 750 ohms. Now, next, what we have to do? We have to list out the things that we know. So what do you know? You already know the formula. So we know that V is equal to IR. Therefore, V is equal to 0.35 times 750. That is equal to 262.5 volts. So this is our answer. Okay, my dear student, you did a great job. Now let's look at another question. Question number 2. A laptop runs on a 24 volts battery. If it takes 1.5 amperes of current to make it run, what is the resistance? So, what do you think? As always, we have to list the given variables. So, V is equal to 24 volts. Current, or I, is equal to 1.5 amperes. Now, what do you know? We know that since resistance is not given, so we have to make make use of resistance formula. So we know that R is equal to V by I. That is, R is equal to 24 divided by 1.5. That is 16 ohms. Hope you are clear. Now, question number 3. It is an interesting question. A toy car has 2 amperes of current. If the car runs on 4 1.5 volt batteries, what is the resistance? When you were young, you must have played with toy cars. Okay, so this question will not solve it. I will give this as a task for you to solve it by yourself. But if you're stuck somewhere else, the hint. Since there are 4 1.5 volt batteries, you need to do 4 times 1.5 volt to calculate total voltage. Then use the formula and solve it. When you solve it, your answer will be 3 ohms. So please check it. Okay, now finally, the last question for this lesson. It's for you to explore, my dear student. The question is, as per the Ohm's law, for the same amount of voltage supplied, current decreases with the increase in resistance. You know that very well, right? Now, find out some of the practical usage of increased resistance in our daily life. So this is where you have to apply the knowledge that you have gained from today's lesson and check its usage in your daily life.
Okay, to conclude, let us look at some key points once again. So in the first section, we try to look at the relationship between current, voltage, and resistance, and that's actually summed up by Ohm's law. And according to Ohm's law, the statement goes, electric current flowing through any cross-section of a conductor is directly proportional to the potential difference applied across its end, provided the physical condition like temperature and pressure is constant. Okay, and in the second section, we try to verify the Ohm's law and we establish a relationship between current and voltage, current and resistance. And in the third section, we try to look at some simple problem using Ohm's law. Okay, that's all from me for you today. Please revise the lesson, go through the textbook, solve the problems in the textbook, and I'll see you all in my next lesson. Thank you.